Hello, everyone. My name is Noah.
And I'm Jack. And welcome to our Europa podcast. In this episode, we're going to be looking at the factors required for life, what they look like on Earth, what they look like on Europa, and
What they might look like in completely different environments elsewhere
yeah.
in the universe.
So, kind of kicking things off, the most obvious thing we have on Earth that all life kind of requires is a good old H2O, just water. There's a lot of really nice properties about water. It is a solvent. It's used in a lot of organic chemistry. Um,
Pretty much all life requires water.
that we know of on Earth, yeah.
Yeah, that we know of on Earth is all sustained in some form or another by water. And our next quality that is essential for life as we know on Earth is heat, and particularly stable heat. There's not one key temperature, there's not some magic number that, hey, if you get to this number, life will suddenly be existing, because we cover a wide range of temperatures on Earth, and life exists across all of them, but they all have some form of heat. They aren't absolute zero.
Right. NASA also has a nice list for everything that they think a planet really needs to have to possibly sustain life. And the first one is water, which we already said, used in a lot of chemistry, and we really just don't know what organic chemistry would look like if we didn't have water. The second thing on the list is chemistry, and this kind of ties in with water, but there are certain substances, certain amino acids and proteins that we just expect have to exist in order for life to exist. Another thing is energy. So we expect there's some way for organisms to get energy so that they can regulate their body temperature, they can kind of exist.
Moving off of NASA's list, we also have atmosphere, which is important for life as we know it on Earth. Now, this isn't saying life can't exist without an atmosphere, but atmosphere is very important for retaining heat, which makes the environment more stable and makes life able to survive and evolve and adapt and continue to flourish.
Yeah. It also is going to be protecting us from radiation and kind of trap the oxygen we need to breathe.
Mm-hmm. Oxygen's pretty nice, I think.
Yeah,
breathing is great. If you ever had the air knocked out of your, the wind knocked out of you, out of your lungs,
it's just not fun.
It's just not fun. No.
Oxygen is great. Atmospheres are great.
Another factor that we have on Earth that's probably pretty important for life is a stable gravity. This one doesn't really need a whole lot of explanation, but if the gravity on Earth were to randomly shift, that would cause a lot of destruction, which would kill a lot of life. And if the planet were in a state where complex life didn't exist everywhere, and it was only like simple life existing in certain areas, this could potentially be the end.
Yeah. So we talk about all these really cool factors that Earth has, but we do need to kind of recognize that when we're looking for life on other planets, we're kind of looking at asking ourselves, so what this planet what factors it would have? What does this planet need to look like? When we ask ourselves that, we need to remember that we have this bias, right? Mm-hmm. Because we just sort of assume that life is going to look like it looks on Earth.
Because that's all the evidence we have.
Right. But when we're looking at at other moons, other planets, we need to consider that things could be different. One thing is that it's been proposed that instead of being water-based, chemistry on other planets and moons could be methane-based.
For fans of the Halo series, you'll remember that Grunt, one of the first enemies in every game, comes from a methane-based planet where they breathe a methane gas to survive, so they have to wear special tanks in order to be able to breathe. And if you blow the tanks off, they explode. And if you have the skull on, it'll make like a little confetti and, that noise. It'll be really entertaining.
They didn't cover that in lecture.
I don't think they did.
That's weird. But yeah, it's really cool how like something in Halo, which is not really regarded as being the most accurate thing, actually is kind of close to what we expect might exist elsewhere in the universe.
So the next factor that might be different is heat, and this is namely in the form of extremophile bacteria. Now, these bacteria exist on Earth. They're bacteria that can survive in extreme cold or extreme heat. So even if the majority of a planet would be considered uninhabitable, there's a chance there could still be some extremophile bacteria that we currently can't see because we aren't sending probes to the surface of Europa in order to check.
Right. Like the weird thing about the extremophiles is, we kind of expect that all things on Earth get warmth from the sun and they need to kind of stay around some temperature. And then extremophiles just kind of throw that out the window and they live in some of the harshest places on Earth. And so why couldn't we expect that things on other planets were also extremophiles to us? We also expect that atmospheres can change over time. So while maybe the atmosphere of a particular planet doesn't look like the Earth's atmosphere now, it's possible millions and millions and millions of years ago, maybe it did.
Or maybe millions of years from now it will.
Right. So we just need to remember that that can change. So we mentioned earlier that there's kind of this list for things that we think we need for life. And while we're not sure that you need all of these things, and they don't necessarily have to be in the form that we commonly think of, the really cool thing about Europa, and one of the reasons why we picked this planet to kind of be our example, is that Europa actually has a lot of really interesting qualities that make it similar to Earth. So for instance, we're very certain that Europa actually has liquid water.
Right, yes. So there is a lot of evidence to suggest that Europa has liquid water, not really on the surface, more of a sort of glacier cone or shell with a liquid ocean underneath that that's sustained by both pressure from the ice and heat from the center of Europa.
Right. According to NASA, there's a lot of evidence to support that beneath that icy shell that we said, there's actually this underground ocean that exists. So we really do have liquid water on Europa. It's really hard to get to. It's under miles and miles of ice, but we really think it's there.
And I believe there's a geyser on Europa that's shooting water up to the surface.
So there are some satellites that have flown by, or rockets that have flown by, that suggest that there actually could be a vent just spewing water out. We're not totally sure yet, but it's looking better and better that might be it. And it's we'll get to this later in the podcast, but that is, we're going to be talking about that in the future. We'll get to this later in the future, but that is an active area of research that people are very, very excited about.
Right.
The other thing we said, one of the other things on the list that you need to have is chemistry.
According to NASA. You know, those guys.
Yeah.
So Europa's surface is mostly ice, just, dihydrogen monoxide, H2O, the same composition we have on Earth, but it is being affected by radiation that comes from being so close to Jupiter.
Right, and so with all this radiation, the hydrogen and oxygen in the water can actually react with stuff on the surface of Europa to create all kinds of chemical reactions. And some of these reactions, they'll form compounds, and these compounds could potentially support life. We also think that if they were to make it to the liquid ocean, that perhaps they could undergo a similar process in our ocean where minerals can cycle through the water. They could actually be cycling through the water, replenishing themselves and sustaining life.
Right. And as previously mentioned, the last factor of NASA's list for things that life needs is energy. So, we are running on energy as humans.
Yeah, there's just like a lot of all the biological processes need energy, like metabolism, homeostasis, reacting to changes in the environment. They all require energy. So on Earth, all of this energy, in some way or another, can be traced back to the sun, but Europa is really far away from the sun, so we don't think that that's where it's getting its energy.
It's more likely that it's getting it from Jupiter, right?
Right. So it's just because of like the positions, this phenomenon called tidal flexing occurs, where the gravities sort of fight each other and they move the planets around, and this energy that we have in the gravitation between the two planets gets converted to heat and actually heats up Europa. It's also possible that some of the chemistry we talked about earlier could be reacting, according to space.com, could be reacting and actually heat up the planet. So moving on from just the stuff we find on Europa that could contribute to life, there's this other really interesting aspect to Europa that we don't know of any other planet that has it other than Earth, and it has a huge potential to make it more habitable.
And that is plate tectonics, which is pretty important on Earth as it affects, a lot of the
Carbon cycle.
the carbon cycle.
It regulates the amount of CO2 in the atmosphere, and it helps move minerals, nutrients on the bottom of the seafloor back up into the biosphere.
And that also includes thermohaline circulation, right?
Right.
Where minerals are taken from the ocean, like the deep ocean, and are sent up to the surface ocean, where different forms of life feed on them. Then when that form of life dies, it will fall back down to the deep ocean, where it will decay, release the nutrients, and continue the cycle.
Yeah. On Earth, we see plate tectonics as these giant chunks of crust, be it oceanic crust or continental crust, kind of moving around Earth's mantle, which is the outermost layer of Earth's core. So on Earth, plate tectonics really involves like lava, and it's hot, and it's how volcanoes are made, it's how continents have drifted apart.
It's how new oceanic crust is formed, and
Right.
how old crust is subducted as it's pressed underneath newer crust and destroyed.
Okay, so plate tectonics on Europa would probably look really different. Brandon Johnson of Brown University was the lead author on this recent article that talked about how on Europa might actually experience plate tectonics as being chunks of ice, that icy shell, moving over the water underneath the surface. Which is just really interesting because on Earth you think of plate tectonics and volcanism as being like lava and hot and volcanoes, and on Europa it really might be
freezing cold.
Right, it's the exact opposite. But on Europa it's ice, it's cold, it's like almost the complete opposite.
So that just ties back into sort of, it's similar to how things work on Earth, but it's just different enough where you can clearly see that while life could exist here, it'd probably be extremely different.
Right. So the other thing, plate tectonics like this could explain that geyser of water you were talking about. Because on Earth we see plumes of magma rising from the mantle, and that's how we get islands like Hawaii. But on Europa, we actually could see that plume of magma be a plume of water shooting out of the ice. Plate tectonics like this could also explain how some of those minerals, according to, again, the Johnson article, how those minerals can make their way through the cycles, and they can actually cycle around, and so they won't run out. All in all, it's very possible for life to exist on Europa.
And it's more likely than on a lot of other places. Thanks for watching. If you enjoyed, be sure to check back next time. We're going to be going over how alien life is portrayed in a lot of science fiction as opposed to how we actually expect life to be found, especially on Europa.